Hello, today we are going to explain how the encoder works and the code of the encoder. First of all, we are going to explain how the encoder works. The encoder have a disk inside it that contain of a lot. This black small rectangle shows, it present the holes inside the encoder. These holes, there are. From one side of the encoder there are two emitters, and the other side there are two detectors. This emitter has a LED light that emitting a light, so the detectors, once it detect any light from these holes, it gives a voltage pulse, like shown in this graphs for emitter A and emitter B. In this graph shows there is for one cycle is 360. This shows one cycle. So we're dividing this cycle into 4 parts. There is a common pulse here between A and B. Okay, so the phase shift between A and B is 90 degrees. This is why this pulse is called quadrilateral pulse. Okay, then this is show the state of each pulse. For example, when A is equal to 1 and B is equal to 1, then the state is 1, is named 1. And for A equal to 1 and B equal to 0, the state is named 2. And when A equal to 0 and B equal to 0, the state named 3. Lastly, when A equal to 0 and B equal to 1, the state named 4. This is when the encoder is rotating in clockwise, but when it rotates in an opposite direction, it gets like 0, 1 first, then 0, 0, 1, 0, 1, 1. So it depends on the direction the encoder rotates. After that, this table shows how the cases the encoder will pass through. First, this present state means the present state of the encoder, and the previous state means the past state. There are 3 cases. First case, increasing the counter. How the counter will be increased by if there are 4 cases increasing the counter. First one, when the present state is equal to 1 and the previous state is equal to 4. And when the present state is equal to 2 and the previous state is equal to 1, and when the present state is equal to 3 and the previous state is equal to 2, and when present state is equal to 4 and the previous state equal to 3. This is shows the counter increasing. Okay, and there is another case, the decreasing counter. This happens when the present state is equal to 1 and the previous state is equal to 2, and when the present state is equal to 2 and the previous state is equal to 3, and when the present state is equal to 3 and the previous state is equal to 4, and last one, when the present state is equal to 4 and the previous state is equal to 1. Other than all these cases, it's called nothing to do. Don't care condition. Nothing. The encoder will do nothing. After that, I'm going to explain the code. First, the code here I'm defining the past state. Okay, outside interruption. Before explaining the code, I want to tell that the encoder has two A and B. Okay, the A and B should be connected to the interrupt of the Arduino. For the microcontroller you're using, so pin incremental A connected to interrupt A connected to pin 2 and interrupt B connecting to pin 3. Then this is the code. Okay, for the before anything we define the past state. Okay, decrement this past state. If like the table shows, if 1 equal 1, A equal 1 and B equal 1, this shows the past state 1, as mentioned before in this table. Okay, then we add 2 timers, one for the present and one for the past. and then we find the difference between the present and the past. But then we calculate the RPM by this function by using the counter and PPR. PPR means I forgot to tell you what is the PPR. Sorry, PPR means the number of holes here available. If the PPR is equal to 1000, then the available holes here will be 1000. This will be more clear in the last the picture of the encoder. I will let you see it. Wait. Then continue. Then we will go to the interrupt. There are present state. The present state is is shown in the interrupt, and there is a switch switch case. First case is case 1. Case 1 means that a present state is equal to 1. Then in case 1 there are two if statements. If the past state is equal to 2, then the counter decrease. If the past state is equal to 4, then the counter increase. Also for state 2, for case 2 means that the present state is equal to 2. So there are also two if statements. When if the past state is equal to 1, so the counter is increase, and if the past state is equal to 3, then the counter decrease. All of this I'm saying is we did say it before in the table, but I'm explaining it again for you in the code. And for the case 3, for case 3 mean also present state is equal to 3. If the past state is equal to 2, the counter is increased, and if past state is equal to 4, counter decreased. Then default means the last case. In our cases, present state is equal to 4. So if past state is equal to 1, counter decrease. If the past state equal to 3, counter increase. Then after finishing this interrupt, the past state is equal to the present state, so the present state will be a new present state. Then this is the encoder we used. Okay, this is the 1000 PPR. This is what I was telling you about the holes, and this shows the terminals of the encoder used. For the brown, like here, the brown terminal is used to connect it to the Arduino and have a range for the voltage from 5 to 24, but you connect it to the Arduino. The blue 0 volt common, this is connected to the ground. The shield is like the aluminium terminal here, is also connected to the ground. The black and white and orange terminals are the output terminals. We only use two, like the interrupt A and B, black and white. Okay, this is the circuit of the encoder to work perfectly. Here the terminal block for the first pin, we connected the brown terminal, okay, and the other side of the terminal block 5 volt Arduino are connected. The 5 volt Arduino are also connected to this side of the resistance, and the other side of the resistance are connecting the black and white terminals. And also at the black and white terminals, pin 2 and 3 of the Arduino are connected. Last terminal here is the blue, and the blue is directly connected to the ground here through this terminal block. Then okay, now I'm going to show you the code slowly so you can see it clear.